So let's talk about what a lens does. Okay, what does a lens do? Well, if I have a light source, right, and let's just use a magnifying glass because everybody knows a magnifying glass, right? So I have light that's coming from this light bulb in all directions. It's an infinite number of photons all the way around, right? And though some of those light rays, they get to the magnifying glass, and the magnifying glass is a focusing instrument, right? It's going to take those light rays and it's going to bend them to a particular point. Right. And many of you know that if you take the magnifying glass and you move it farther and closer to a surface, right, you can make that focal point wide, and then you can make it really, really, really bright, right? Because you've got all the light focusing in one particular area. And if you were a really mean kid, then you'd, do things to little ants and stuff like that. Terrible, terrible. You shouldn't do that. But understand, light rays, magnifying glass, and then, right, they focus to a focal point. That's a very important point. So let's extend this now to a simple camera setup. So I've got a light bulb. Same thing. I have a light source. It could be the sun. It could be ambient light that's just bouncing around in a room, whatever. And that's going to go and it's going to hit an object. Let's call it our ant. Now, light rays are going to bounce off of the ant and they're going to go to a lens. The lens acts as a focusing instrument. So those light rays are going to be bent and they're all going to go to a focal point. But the light rays don't stop there, right? Even though they focus, it could be in the middle of the air or whatever inside of your camera, but they continue to focus, right? Or they go to the focal point, but they continue on. They cross there and they continue on. Well, once they continue on, they can be projected onto a sensor. It used to be a film camera. Now it's a digital sensor. And now what you have is a representation of the ant on a sensor. Okay, so we've gone from a light source. We have light, which is bouncing off of this particular ant. And this is a 3D ant. So this is an object in 3D space. The light rays go through the lens. It focuses it to a focal point. The light rays continue, and then it projects it onto a flat two-dimensional plane. So we've gone from the 3D world here, right? This was a 3D object. And then we've gone to the 2D world here because we've projected it onto a two-dimensional plane. And if you just look at this system that's right here, I've got the makings of a very simple camera. Light comes in, gets focused to the focal point, and it gets projected on a two-dimensional sensor, right? So we've lost something. So you can think of photogrammetry as going backwards, okay? Now I've got the photograph, right? I've got this photograph that's two-dimensional. And if I pick, let's say on the bum here, I pick something on the ant's rear, and I go backwards now. I'm going to pick that pixel that's on there, and the light ray travels in a straight line. So it's going to go back through the focal point, back through the lens, and back out into the 3D world, right? And at some point, this is going to cross the ant's bum in the 3D world. So I've gone from 3D to 2D. I've lost some information, some of the 3D information, and now I'm trying to go backwards.